Okay, next one I want you to look at is on page 362. Down at the bottom, there is a picture drawn of a triangle that is labeled as follows. And the directions here tell us to, it says, let theta be an acute angle such that the sine of theta is equal to 5/6. So keep in mind that would come from a drawing like this where we have the opposite 5 and the hypotenuse 6. Okay. So they told us the sine of theta. They didn't tell us what theta is, notice. Okay, but they just told us what the sine of theta is. So we can set up a true sentence there. Alright, now the question that we're going to be asked here, this is another skill that we're going to need to be able to do besides memorizing those trig values, okay, is what would be the cosine then of theta? Okay, and again, without knowing theta, without figuring out what theta is, can we figure out what the cosine is? Well, the answer, of course, is yes, but we got a Pythagorean theorem issue here because we need to know what this x is. Okay, so if I do my 36 and then a squared plus 25, okay, and I subtract, here I'm going to get 11 equals a squared, so radical 11 would be my a. So if I know that x equals radical 11, now I can find the cosine because the cosine would be the adjacent over the hypotenuse. So I'd have radical 11 over 6. So without actually knowing the angle, okay, I could figure out what that trig function was equal to, okay, based on the fact that I know the adjacent side and I know the hypotenuse. How about the tangent of theta? Tangent of theta would be the opposite over the adjacent, so it would be 5 over radical 11, which of course we can't leave like that. So it would be 5 radical 11 over 11. Cosecant is going to be the flip of the sine, or hypotenuse over opposite, 6/5. Secant is going to be the flip of the cosine, 6 over radical 11. And once again, can't leave it like that, so it'd be 6 radical 11 over 11. And then finally the cotangent. It's going to be the adjacent over the opposite, so it'll be radical 11 on top, 5 on the bottom, which would be the flip of the tangent, of course. Okay. And that would do it. So in this case, we can still find the trig values, even though we don't have a nice angle, not a special angle, a 30, 60, or a 45. Okay, we can still find trig values as long as we know some of the side lengths. Okay, and as long as we know 2 of the side lengths, then we really know the third too because we have the Pythagorean theorem we can use. Okay. All right. Another problem this is a similar problem to what we've done in the past here with solving right triangles. In this case, it says we have a side length 6. The angle here is 27, and we want to find the measures of the two angles, the other two angles, and the lengths of the other two sides. Well, of course, we already know that one is 90. What about this one then? What's that angle going to be? If that's 90 and that's 27, that makes 117. 117 from 180 would be 63. So we know that angle would be 63 degrees. Now, we can't use the Pythagorean theorem here, of course, because there's only one side. However, we could set up a trig function here and figure it out. Let's say we wanted to find b. Well, for 27, b would be the opposite. 6 would be the adjacent. So that would lead me to set up a tangent function. So we'd say tangent 27 equals b over 6. And from there, if we want to solve that for b, we can multiply both sides by 6, kind of like what we did earlier today. And so if I do 6 tangent 27, we get 3.057. So that would be the length of b here. And similarly, if we wanted to find c, we could recognize that c is the hypotenuse, 6 is the adjacent, so that would lead me to cosine. So we'd say cosine of 27 equals the adjacent, which is 6, over the hypotenuse, which is c. And this is going to be like the last one we did in our warm-up today. If we're going to solve this, we're going to want to multiply by c like Cody did, and then divide by the cosine 27. So we'd have c times cosine 27, and then if we divide by cosine 27, we can find our c. So let's go ahead and do that. 6 divided by cosine 27 turns out to be 6.734. And with that said, we can use trig functions to solve these right triangle problems. Okay? So part of our work is going to be doing that. And again, solving right triangles is similar work to what we've done in our previous classes, so that is not something new. Okay. All right. That is it for today. Or no.